All right, today we are determining transformations. So what's going to happen today is that you're going to be given an equation of something, say y equals x squared plus 2, and you're going to be asked, what's the transformation to take y equals x squared, for example, to that, to y equals x plus 2. And so you'd identify, in this case, pretty simple, identify that 2 there, it's a translation, positive 2 in y direction. All right. So what we really want to try and focus in on doing here is without, mathematical language. All right, so things like translation positive 2 in y direction rather than, moves up 2. All right, so you need to be a bit more sophisticated without mathematical language. All right, so here's an example. Find a sequence. And so I'll just mention this now. When it says a sequence, doesn't necessarily mean there's one sequence. There could be others, but they just, when they're writing the questions, they just always say a sequence. All right, so there could be others. So if you've got a different one to what's in the back of the book, doesn't necessarily mean that yours is incorrect. All right, so in this one here, we're starting off with the graph of y equals x squared, and we do some transformations and we end up with this one, y equals 2 bracket x minus 2 squared plus 3. So what we're looking for is, what are these transformations? Now, the best way is to have a look and see what happens. The best way is you start with x. Okay, so we start with the x. And so what do we do to the x first? Well, the first thing we do to the x is we've got this minus 2. All right, so we've got the x and we've got this minus 2. And so what does this minus 2 do? All right, in terms of just inspection, this is what we're doing. We're doing inspection, that's what it's called. So we're just looking at the minus 2. All right, so in this particular case, the minus 2 is a translation, and it's a translation of positive 2 in the x direction. Or of 2 in the positive x direction. Okay, so for the examiners, you shouldn't use the shorthand like I'm using. Right, so that's the first one. So that's what that 2 does. Then we've got another 2 as well, this one out the front. All right, so we do our translation of 2 in the positive x direction. We then do the squaring thing. That just shows us that what shape the graph is. So that's not what we're asked about here. Well, we're asked about some transformations. Then we've got the the other one there, the other two, I should say. So what does that 2 do? Well, it's a dilation. Factor 2 from the x-axis. So there's that transformation. And then finally, the last thing, I'll go to red on this only because I've got red left. The only one I've got left is that +3 on the end. So what does that +3? Well, that's a translation of 3 units in the positive y direction. Oops. All right, so if we want to stretch that out and write that out in full, that's what we should write. All right, so that method that I've just used then is it's just inspection. All right, and I think it's good practice, as I said, to always start with the X and work that way. So this sequence would work. There would be other sequences. All right, so let's not worry about what those other sequences might be. So if we start with the X and work out. All right, then we get things here. This one's a little bit more, it's got something, sorry, a little bit more. It's not really a little bit more involved at all. But there's something in the way that our y equals root 5x minus 2 is written that we need to take care of. What we need is, if there's a factor of, in this case 5x, what we need to do is we need to take that number, the 5, out as a common factor. All right, so that then means this 2 there, change that to 2/5. All right, so just dividing by 5 by 2. We need to have this 5 out the front of a bracket like that. Doesn't make a difference to the 5, but what it does make a difference is to this translation here. All right, so unless that 5's out there as a factor, and you've got that the rest in the bracket, you won't get that translation correct. So that translation is, we've got a translation of 2/5 units in the negative x direction. Okay, and then the next thing, of course, is we've got this 5 here. So yeah, comparing, of course, to y equals root x. Didn't mention that. All right, so this 5, well, what's the 5? The 5's the dilation. Now remember, this is the tricky one. Because it's inside the function, because it's inside the square root. See, whereas in the previous example, the dilation 2 was outside after the squaring had been done. So we take x, we have x, take 2, we square it, then we multiply. Whereas this one here is have x, take 2/5, multiply, then square root. So we're multiplying by that factor before we do the function thing. And so what that then is, because it's inside that function, it's a dilation from the y-axis of factor, and remember this is the one that's funny, factor 1/5. All right, so it's the position that factor is. So it's here, it's inside the function, inside the square root. So it's from the y-axis, whereas this one here, our first example, it's after we've done the function, so it's after we've done the squaring. All right, so here we do our squaring first, then we multiply. Whereas here, we multiply first, then we do the square root. All right, so just got to be a little bit careful with that, kind of get that straight in your head. All right, now these ones are a little bit more tricky because we're starting with this stuff and then we end up with that as our image. So what we need to do, so I'll write our image and I'll write it with the image with the dashes to indicate it's the image. What we need to do is we need to get our original looking similar. So what we need to do here to our original is we need to first of all take 6, so y minus 6, and then we need to so taking 6, then we need to divide by 3, and so you've then got y minus 6 over 3 is equal to 1 over x minus 1 squared. All right, so now we're comparing our image y to our original, and we're comparing our image x to our original. All right, so in terms of the y's, so our image y, what do we do? So we translate and then we dilate, don't we, here? And for the x, to get our x image, just looking at the x part, because the squared part's the function and that's the same in both, but it's what's underneath that, x minus 1. So what transformations are possible there? All right. So what are we doing? All right. Let's have a look carefully at what they are doing. Now, let me rewrite both of those in the next page. So we've got y dashed equals y minus 6 over 3. And the other one is x dashed is x minus 1. All right. So we've got, let's look at the x first. So we've got a translation. One unit in the negative x direction. All right. Then from the y's, well, what do we got here? We start with our y, and then what do? We start with our y. What do? We take 6. So what's that? That's a translation. 6 units in the negative y direction. All right, then we've got this divide over here. This is divide. So we've got this divide by 3. that we've got happening. So dividing by 3 is the same as multiplying by a third. And so when we are using this, we use the term, it's always referred to as a factor. So we never refer to anything as dividing in this case, for these transformations. We always refer as a factor. And so a factor implies multiplication. So we've got a dilation factor of 1/3 from. Now the question is, which axis is it from? Now the way we decide that is we have a look at what we're doing. So here what we're doing is we're changing the y value. So which axis, when we change the y value, does it, in this case because it's factor a third, get closer to? Does it get closer to the y-axis, or does it get closer to the x-axis? And of course, if you're making the y value a third, it's moving closer to the x-axis. All right, so there's 3 of our transformations, and there's our 3 a sequence. It's asked, sorry, I lost my train of thought there. So it's asking for a sequence, and so there's a sequence. That would take you from this one here to that one there. All right, let's have a look at another example of that kind of thing. All right, so now we've got this 5x minus 1 squared and plus 6, and we're then taking that to our image, which is just x squared. All right, so if we have a look, y equals 5x minus 1 squared plus 6. So we need to, because our image has just got the x stuff in the bracket squaring, and it doesn't have a number on the end here. All right, when they get really tricky, not that we have to do that this year, I don't think, but when they get really tricky, you've then got some more stuff over here on your left. And so you might have numbers here. But anyway, we don't need to worry about that today. So we're going from here back to just our normal x squared graph. All right, so let's take 6 from both sides. So y take 6 equals 5x minus 1 squared. All right. And that's about it. We don't need to rearrange this any more than that. All right. And so we can have a look and we can see what we would do. So our y image is our original y take 6. Our x image is 5 lots of our original x minus 1. All right, so this one here, the one for the y, is a translation. Six units. Ugh. 6 units in the negative y direction. All right, now this one here for the x, let's have a look. Now, when we have our factor 5 in front of our x, and this is just one way we can describe these transformations. There would be other ways we could describe them, but I'm just going with what's written here because that's a times, 5 times. It's a factor. And remember, it's next to the x. So when we come over and look at over here, see, we're multiplying the x before we do our squaring, right? So if it's before we do our squaring, that means it's a dilation from the y-axis. All right, so we're changing the x value. So the x value changes, that mean moves in or out from the y-axis. And now remember, when it's from the y-axis, the factor is 1 over whatever that number. Remember, that's the tricky one. So I'm saying it's factor, actually it's not factor 1/5, it's factor, the way it's written there, it's factor 5. So we're multiplying our x by 5. Sorry, and that's because in here, if you thought we're going backwards, we're going backwards from this to that. So it's by a factor 5 of our x. Yeah, so we're making x bigger, so 5 times bigger, so we're moving it away. And then the 1 on the end, the negative 1 on the end, of course, is a translation. One unit in negative x direction. All right, so sorry, I sound a little bit vague sometimes in those, because you just got to be careful with these ones. So when we're going from something back to our standard, we can get a little bit confused about what we're doing, because we're going backwards. So normally you'd be going, yeah, factor of maybe 1/5, but because we're going backwards, we've got to go back to that. We're going, yeah, back. Then it becomes the opposite, and that's what makes these ones where we're going back tricky. So what you need, the best way of doing it is like this mapping kind of thing that I've done here, and then you can read just straight off without having to worry. You can read straight off without having to, and I was second guessing myself. And then you just literally, once you've got it in this form here, where your image is something to do with the original, then you can just read straight off. All right, so this is a little bit tricky. So the first couple of questions we did when we're going, all right, so from our standard garden variety one to something else, that's not too bad. All right, you can do that by inspection quite easily by just reading. But when you get to these ones here, where we're going backwards, so we're going from something here and we're going backwards to that, you can't just inspect this one here and say, well, this is what it is, because we're going backwards. It's where you get confused. All right, so that's why I've used this technique that I've used. All right, so that's it for determining those transformations. So this is exercise 7D. Questions, take a bit of care on with these. There's just a couple of questions there, but take a bit of care. Question one's okay. You can do inspection for that if you want. So inspection's okay. Question 2, you need to use that other method, because if you try and, they're all ones that are going backwards. So inspection can be a bit more tricky. All right, so got any questions, need help, make sure you give me a yell.